Good morning, Year 10, and welcome to another week of home learning with Miss Pitt. Woohoo! So, on your student worksheet for today that you've been assigned, I would like you to complete the retrieval quiz as you would at the start of every lesson. So, pause this lesson video, go to your tab where you've opened up your student worksheet, and highlight your multiple choice answer for the retrieval quiz question. So the first question should read, a reaction that absorbs energy from the surroundings is. So you need to pick, is it exo or endothermic? So pause this lesson video, go and complete the retrieval quiz, come back to the lesson once you've finished your quiz. Shouldn't take you any longer than 7 minutes. Okay, so let's go through the answers. You can mark your retrieval quiz on your Google Documents, change the font colour to green, use a / to tick it, write over it to correct it. So number 1, a reaction that absorbs energy is endothermic. A reaction that gives out energy to the surroundings is exothermic. A reaction that feels colder is endo. A reaction that feels hotter is exo. An example of an exothermic reaction is combustion. An example of an endothermic reaction is photosynthesis. The process that separates ionic compounds is electrolysis. The ion that will move to the positive electrode must be the negative chloride ion. Chloride ions are best described as halide ions. Remember, they're halogens from group 7, so they form halide ions. And when do ionic compounds conduct electricity? When dissolved. So at the end of your retrieval quiz on your student worksheet, can you give yourself a mark, a score out of 10, please? So it would say retrieval score equals ... out of 10. Can you fill in the score that you got? Okay, so the learning today. The title is Reaction Profiles. Now remember, this topic is all about energy changes in chemical reactions. So the title is Reaction Profiles. The learning intention is to be able to describe reaction profiles. And the keywords, well, we know the first 2 keywords from last lesson. So we know exothermic is a reaction which releases heat energy to the surroundings. Endothermic is a reaction that absorbs heat energy from the surroundings, therefore it feels colder. And a new keyword for today is activation energy. Now, the activation energy is the minimum amount of energy needed for a reaction to happen. So it activates the reaction, it starts the reaction off. So it's the amount of energy needed to start a reaction. Okay, so just to quickly recap from last lesson, we looked at 2 different types of reactions, exothermic and endothermic. Now, exothermic reactions release energy in the form of heat energy, and that's why they get hot. So this is how I remember it. Exo, to give out, X referring to exit. If you exit somewhere, you go out of it. So X means out, heat energy being given out. Exothermic. And remember, guys, thermic just relates to heat. So exo, giving out, thermic, heat. For example, combustion reactions, burning. Now, endothermic reactions absorb energy, they take in the heat energy, and that's why it feels cold, they get cold. And N, I think of entrance, where you go into somewhere. So endothermic, endo, into, thermic, heat. So exothermic are reactions that give out heat energy. Endothermic reactions take in heat energy. So your first task on your student worksheet for your deliberate practice is to complete the table below about exothermic and endothermic reactions by placing a tick in each correct box. You will need 4 ticks in total. So pause the video, go and complete task 1 on your student worksheet, come back for your answers. Oh, hi there. I hope you're ready to mark your answers. So heat energy is given out, should be exothermic. Heat energy is taken in, should be endothermic. Temperature goes up, exo, and the temperature goes down, endo. Okay, so how do chemical reactions actually happen? What causes this energy change in a chemical reaction? So take a moment to think what's going on. So here we've got our reactants. We've got our hydrogen molecules reacting with our oxygen molecules. They're reacting together. There are reactants. They make our product, a new substance, water, 2 water molecules. But what's actually causing the energy changes in this chemical reaction? Think about it. Why do they react? How do they react? Okay, so in a chemical reaction, for a reaction to happen, the bonds in the reactants first need to be broken. If the bonds aren't broken, new products can't form. So bonds must be broken in order for new bonds to be formed. And in order to break those bonds, we know from last lesson that it takes energy. So if I looked at this reaction a little bit differently, if I drew out the hydrogen molecules with the bonds, the chemical bonds in between, these lines represent a chemical bond. So these bonds must be broken and new bonds are formed. And that is what causes the energy change. Remember, guys, breaking these bonds in the reactant molecules requires energy. So energy is taken in. And when the new bonds form, energy is given out. So let's look at an example. So you can see here in this diagram, you've got molecules moving around. Now, in order for a chemical reaction to take place, the reactants must collide with enough energy. So when a reaction takes place, the particles reacting, the molecules reacting, the reactants are all moving around mixed together. They only react when they collide with enough energy, and that energy is known as activation energy. You can get collisions happening sometimes without enough energy and there's no reaction. So, for example, when you turn on a gas tap in school, automatically there isn't a fire because there's not enough activation energy to set the gas alight. So what we do is to increase the activation energy, we add a flame, we give it a spark, and that gives it more energy for the particles to collide harder and actually react. So the key point I wanted to get from this slide is when chemicals react, they must collide with enough energy. And that energy to start a reaction is called the activation energy. It activates the reaction, it starts the reaction. So sometimes we can add energy, we can increase the energy in a chemical reaction at the start by adding a flame or adding a spark. Okay, so we can use a reaction profile, which is a graph that shows how energy changes in a reaction to represent what happens in a chemical reaction. So what you'll notice with the graph is on the y-axis, you've got the energy, the increase in energy. And along the x-axis at the bottom, you've got the progression of the reaction. Whoopsie. So along the bottom axis, you've got the progression of the reaction. So as the reaction's going on, what is happening to the energy on the y-axis? Okay, so A is the energy inside of the reactant. So remember, at the start of a reaction, we always begin with reactants. So A represents the energy at the start of a reaction in the reactants. Now, you'll notice that the graph has got this high hump, okay? A curve that goes up. Now, B on this graph is showing me the activation energy of a reaction. So the energy needed to start the reaction. And the very top of that curve is where the activation is. Now, once the reaction starts, the energy begins to change from the reactants to the products. So D is showing me the energy in the products. So you can see A is the energy in the reactants, D is the energy in the products. And you can see that the energy in the products is lower than the energy in the reactants because your energy is on the y-axis. A is higher than D. So A, the reactants, begin with more energy than the products. So what's happened to that energy? The energy has been given out. So this is a reaction profile that shows an exothermic reaction. It shows the change of energy between the reactants and the products. So if my reactants have more energy than my products at the end, energy must have been given out. It is an exothermic reaction. Now, C shows the total change in energy from the reactants to the products. So A, just to recap, shows the reactants in a reaction. B shows the activation energy. C shows the overall energy change. And D shows me the energy in the products. So reaction profiles show the change in energy during a reaction between the reactants and the products. Now, if the products have less energy than the reactants, the energy must have been given out. Therefore, this is a reaction profile for an exothermic reaction. So what I would like you to do is go back to your student worksheet, click the link for the video for task 2 and watch it. Normally, I would embed the videos into my lesson. However, the quality is very poor when I do that, and you can't hear the sound. So pause the lesson video, go back to your student worksheet, complete task 2, which is just watching this video on reaction profiles. Come back once you've done that. Okay, so I hope you enjoyed the video. I hope it made reaction profiles a bit more clear, especially when you're at home learning this from home. So we know that we've got exothermic reactions. They give out heat energy. So the reactants have more energy than the products because the energy has been given out. We have endothermic reactions where heat energy is taken into the reaction. And if heat energy is taken into the reaction, the products end up with more energy than the reactants. Now, each of these reactions have got a different reaction profile. So if we look at the exothermic reaction profile, remember you've got the energy on the y-axis, you've got the progress of the reaction along the x-axis along the bottom. So you begin with your reactants. The reaction takes place and you end up with your products. Now, what you'll notice is the reactants have more energy because they're higher on the graph than the products, which means that energy is being given out overall. So this is a reaction profile for an exothermic reaction. Remember, exothermic, the reactants have more energy than the products, therefore the energy has been given out. Now, on an endothermic reaction profile, the reactants begin with less energy than the products. Remember, in an endothermic reaction, energy is taken into the reaction. So the reactants have less energy. When they react, they take in energy. Therefore, the products have more energy than the reactants. And this is shown by the products being higher up on the reaction profile graph. Now remember, the top of the curve shows the activation energy, and this green arrow shows the total change in energy. So on the exothermic reaction, the overall energy is going down, therefore it's exo. On the endothermic graph, you can see that the arrow is going up, showing energy has increased, it's been taken in, meaning it's an exothermic reaction. So all you really need to know from this to remember is that on reaction profiles, on reaction profile graphs, if it's an exothermic graph, your reactants will have more energy than your products. If it's an endothermic graph, your reactants will have less energy than your products. So task 3 on your student worksheet is learning how to draw reaction profiles. Again, all you need to do is click the link provided to watch the video. Pause this lesson video, go and watch the YouTube video on drawing reaction profiles by following the link on your student worksheet. Come back once you've done that. Okay, another great video. Brilliant. Now, what I would like you to do is task 4 on your student worksheet shows this graph. I would like you to decide which letters on the graph represent the following points. Which letter is the reactants? Which letter shows the products? Which letter shows the activation energy? And which letter represents the overall energy change? So pause this video, go and complete this task on your student worksheet by adding in the letters for your answers, and then come back to find out if you were correct. Okay, so let's go through the answers. So the reactants were A, the products should have been C, the activation energy should have been B, and the overall change in energy should have been C. A, C, B, D. That leads us on to task 5, which are your progression questions. Now these questions are multiple choice, A, B or C. So all I want you to do is highlight your answer and change the colour of it, or highlight it using the highlighter icon, or tick it using the /, and then come back to check your answers. So pause this lesson video. All of these questions are on your student worksheet. Complete the task. Come back once you have done that to green pen your answers. Okay, so good work. Let's green pen our answers. Remember, you can use a / and change the font color to green to mark your work ticket, or change it if you need to. So the piece of apparatus used to measure temperature is a thermometer. The term given to a reaction which transfers heat energy to the surroundings is exothermic. When barium hydroxide and ammonium chloride react, the temperature of the mixture decreases. Well, if it decreases, it must be endothermic. On a reaction profile, the height of the hump shows the activation energy. When calcium reacts with water, the temperature changes from 18 to 39 degrees. Wow, that's a big temperature rise. Which statement is correct? Well, if it's an increase in temperature, it must be an exothermic reaction. Now, what can you deduce? What can you work out from the reaction profile? Well, I can see my reactants are lower than my products, which means it must be an endothermic reaction. Well done if you got that one correct. Now, that leads us on to our last task, our consolidation questions. There are 4 consolidation questions. I'd like you to pause this lesson video, go and complete them on your worksheet, and come back for your answers. So let's have the answers then. Number 1, a reaction profile shows the energy changes during a chemical reaction. You might have said it shows the difference in energy between the reactants and the products. That's absolutely fine. Number 2, the amount of energy needed for a reaction to start is known as what? The activation energy. It activates the reaction, it starts it. So, for example, when you are lighting a match, the activation energy is the strike of the match because it causes friction and it causes a spark. Number 3, if the energy of the reactants is lower than the products, then the reaction is, the reactants are lower than the products, so the products must have more energy, so they must have taken energy in from the surroundings, therefore endothermic. If the energy of the reactants is higher than the products, then the reaction is, so the reactants have more energy than the products, so the energy must have been given out during that reaction. If energy is given out, it must be an exothermic reaction. Give yourself a score out of 4 on your student worksheet for this task, please. And as we usually would, we are now going to complete our final RAG rating for this lesson. So let's just quickly recap. The learning intention was to be able to describe energy reaction profiles. Are you red, are you amber, or are you green for this learning intention? So pause the video, complete your RAG rating on your student worksheet. Thank you for completing this lesson and accessing your work from home. Again, I know it's not an easy task, so I do appreciate the time and effort you put into your work from home. Thank you, Year 10, and I look forward to our next lesson.